My transformed function, I'm going to call g of x. And I'm going to do this generically with just using the function notation so it works for any function. So we have a, and then whatever our function is, that's the f, that's our function. Inside that function, we have b x minus h plus k. So this is that general form. That f of x could be x squared or the square root, the absolute value, the cubic, it could be any function. So f of x is the parent function, whichever one I'm using, but inside the f is all of this stuff with the x. Now, I'm going to use some different colors here to help you.
Wait, is that an F?
This right here, this is an f. Yep. So if we talk about the a value, do you remember what the a value does? Positive or negative. So if it's negative, what happens? It does stretch if it's a number, but if it's negative, what happens? It reflects, right? And it's outside the function, so it's vertical. So if we're reflecting it vertical, which axis are we reflecting across? The x-axis. Okay. So then if it's greater than 1, or I should say if the absolute value is greater than 1, now those don't look like absolute value symbols, but that's what that is. If the absolute value is greater than 1, somebody said a minute ago, what does it do? It stretches. So this is still vertical, so this is a vertical stretch by a factor of whatever the number is, right? If it's between 0 and 1, so if we have it 0, a, and again, this should be the absolute value, but so what will it do now? It'll shrink, so it's vertical. And shrink is one word, and you'll see that in some textbooks. I don't really like it, but I don't like the word shrink. It's a vertical compression. If you think about when you study in physics and you're talking about a spring, you're not shrinking that spring, you're compressing that spring, right? It isn't actually getting smaller. It's just compressing it vertically. Next, we want to look at the b values. This is inside the function, but not inside with the x and the minus h. So when b is negative, it reflects across the y-axis. When it's greater than 1, it's a horizontal shrink or compression. And when it's between 0 or 1, it's a horizontal stretch. All right, now look at the h part. The thing about h is you have to remember that x minus is the formula. So when h is positive, what you're going to see is x minus, so let's say h is 2. What you'll see is x minus 2, because this is the formula and this is h. You will see x minus 2 if h equals 2. If h equals positive 2, you will see x minus 2, because the minus is part of the formula. If h is negative 3, what you would see is x minus negative 3, right? Here's my h. But we don't ever write that. We change it to a plus, don't we? So what you will see is x plus 3. So this one is moving right. And if x, oh, that should say h. I'm sorry. This is not. Oh, wait, that's supposed to be x. If h is positive. So then if h is negative, sorry. So make the correction. I had written an x when I should have written an h over here. When h is positive, you see x minus 2 because h is positive 2 and you go right. But when h is negative, it's x minus the negative 3. So you will see x plus 3 and you will go left. Okay, that tends to be confusing. So do you have questions? When you see x minus 2, that means h is positive and it goes right. When you see x plus 3, that means h is negative and you're going left. All right, now let me give you one thing that it's a little tricky. If I asked you what does negative x plus 2, if this is my function, and I asked you what transformations had taken place. Oh, wait, it has to be inside so you know what's going on. That looks like a linear. So let's see, I've asked you about this. You're going to get the reflection right because you know that this is B and it's going to reflect across the y-axis. The problem here is the formatting. How does this look different from my function up here at the top? It doesn't have A or it doesn't need the F because I've given you the function. It's squared. It doesn't have an A, but that's okay. That just means A is positive 1, right? Yes. So look at how this B and the x minus h is written. Do you see all those extra parentheses? Do we have those extra parentheses here? No, we don't. What that means is the minus sign hasn't been factored out. What this really is negative x minus 2 with the double parentheses. Do you see the difference? If I distribute this minus sign, I will get negative x plus 2. The problem is you almost always see this example or something like it on a test, and you're going to tell me it reflects across the y-axis, which is correct, but you're going to tell me it moves left too, and that is not correct. It's going to move right too. The problem with it is the extra parentheses are not there. So in order for you to know for sure, once you get used to it, you can just think in your head, oh yeah, that minus sign needs to be distributed, so that would be a minus 2 and it's going right. But in the meantime, you would factor out the minus sign so that you have this extra set of parentheses here so that you would know that it's going right 2 units and not left. Are you confused? Okay, some of you are. In the formula, the B has to be factored out, right? So in whatever function this is in, this could be my absolute value function, right? Whatever function it's inside of, the B has to be factored out from the x minus h. If it is not, the plus or minus sign doesn't tell you whether it's going left or right. And it's also true about stretch and compression. If I had negative 3x minus 6, right? The negative 3 is telling me it's reflecting across the y-axis, and the 3 is telling me that it's a horizontal compression, but it looks like it's moving right 6 and it's moving left 2. Because if I factor out that negative 3, I get negative 3 times x plus 2, and so it's really moving left 2.
It's the opposite.
You have to factor out the b. The b has to be separate outside the parentheses. Do you understand what I did? Do you understand what I did from this one on the left to this one?
Yep.
Questions? I factored out the negative 3. And I had to factor it out so that I know it was going left 2 and not right 6.
So it must always be in that number.
I'm sorry, what?
You always factor it out.
You always factor it out, or you don't know which way it's moving. For this final piece of transformation notes, the plus k at the end works just as you think it would. Plus k shifts up and minus k shifts down. Now, to wrap it up and summarize, a and k are outside the function. These two are both vertical transformations. A stretching vertically or compressing vertically or reflecting vertically, and k shifting up or down vertically. B and H are both horizontal. They are inside the function. B is a horizontal reflection across the y-axis. H is a horizontal transformation left and right. B is a horizontal stretch or compression based on the value of B. And for this final example, f of x equals negative the square root of x minus 4 plus 3. The negative is going to reflect across the x-axis. The x minus 4 will move right 4, and the plus 3 is the k value at the end will shift up 3. This concludes our notes on transformations of functions.